Hi, I'm Yumi Nishihara from the University of Tokyo. Today I'll be presenting magashi, fabrication of shape-changing edible structures by extrusion-based printing and baking. Due to the development of 3D food printers, it has become easier to print customized foods in different shapes and internal structures. Though extrusion-based printing is a simple and quick process, it often creates a distinct texture on the surface of the food. Thinner layers could be printed to improve the resolution, but this would prolong the printing time. In recent years, several shape-changing foods that promptly transform into 3D shapes in response to external stimuli have been proposed. For all these cases, the food is created from sheets, which need to be handled and cut by hand. Furthermore, they mainly focus on the overall shape of the food. In this research, we propose magashi, a 4D food printing method which enables users to design shape-changing food in different shapes with intricate patterns. By using extrusion-based printing, we aim to fully take advantage of the fabrication machine's precision and the user's creativity to print intricate patterns. We also use the shrinkage and deformation that occurs during baking to make the printed material bend into 3D shapes. The printing patterns and thickness controls how the material dries and determines the direction it bends. Thin linear patterns use less amount of material and have less moisture content, which induces it to dry faster and bend upward. Thick sheets dry slower from the outline towards the center. Rather than bending upward, each side bends inward, pushing the center of the sheet up and making a dome-like structure. For the printing material, we use 3 ingredients: rice flour, starch syrup, and water. In addition to off-the-shelf ingredients, we also used available equipment and software to print and bake the material. The fabrication method of magashi consists of 4 steps. Once the ingredients are mixed, material is printed on the printing bed covered with non-stick aluminum foil. When the print is finished, the printing bed is placed in the oven to bake. Linear patterns require to be dried as they continue to bend after baking. Through our experiments, we found that the different parameters can affect the baked shape. For thin linear patterns, the line's length and width can affect the baked shape's curvature. For thick sheets, the thickness needs to be at least 0.5 mm for it to bend downward into a stable shape. Using our method, we made several foods and objects that bend into shape when baked. Monaka is a Japanese sweet consisting of 2 wafer shells and an azuki bean filling. Though the sheets are conventionally made by using molds, we propose to use magashi to create shells with intricate hole patterns. The food's design can be fully customized with our method, as opposed to only using molds. For foods such as fortune cookies and cigarette cookies, it's common to create the 3D shape by baking sheets of dough and bending it while it's hot. In the case of magashi, it's possible to print intricate mesh patterns and bake them to self-wrap without bending the food by hand. In addition to the food, as a concept, we also made edible cutlery. Baking the printed material causes the fork to bend upward and the spoon to bend downward into its final form. Using extrusion-based printing, it's possible to fabricate multiple cutlery in different shapes and sizes according to the user's needs. Magashi has simplified the fabrication process of shape-changing food and can enable the user to create food in different shapes and sizes while also incorporating intricate patterns. Through our experiments, we found that the printing material's viscosity slightly varied on a daily basis, which affected the baked shape. We hypothesized that it's due to the environmental influences. By printing and baking in different room temperatures and humidity, and recording the output results, it would be possible to develop a simulation tool that could not only predict the 3D shape, but also determine the optimal printing material and settings, which will further simplify the fabrication process. In addition to aesthetic patterns, magashi could possibly be used to influence the eating sensations of printed food by adding texture to the food's surface. For example, adding distinct textures could affect the mouthfeel, while creating intricate textures could control how liquid sauces adhere to the food through capillary absorption. Through our experiments, we also found that by adding more layers and baking it at a higher temperature, the material can expand. By applying this method, users could potentially broaden the shape changes of printed food beyond bending. Thank you.